Have you ever wondered what those structures are on your plants? Is it something you should be worried about, or is it completely normal and part of what the plant is meant to do? Let's dive into part 2 of this series. Hi, my name is Memo, this is my channel, Houseplantygoodness, and essentially it's a place where I like to geek out about my big passion. You might be able to see somewhere behind me, it's tropical houseplants. Now I'll start off with a bit of an apology about the darkness, but at the moment it is a freezing cold in the UK and very overcast, so my lights are doing the mostest. Bear with me during these grey days. Now that that's out of the way, this is a continuation in what might become a bit of a longer series when it comes to plant structures and maybe some things we should be worried about on our houseplants or not. I have done the first video and I'll link it at the top there for the people that haven't seen it. But for everybody else or people that are just stumbling onto this for the first time, welcome. And let's dive into some further plant structures. Now there's quite a few things that I want to cover on today's video. One is going to be the kind of hairy plants. The other is going to be sometimes when you see some liquid on your plants. We'll also talk about what those white things are when you're water propagating with some plants, if it's not quite a root and it's not quite a leaf. Whether or not, and I know this is not technically part of a plant structure, but it grows near a plant sometimes when you start seeing things like mushrooms growing in the soil. And we'll also talk about some interesting adaptations that certain plants, like for instance begonias, have when it comes to propagating. Those topics and many more are what I'm going to be covering in this video. So without further ado, we've got a lot to cover. Let's dive into the first one. So starting off strong, and ironically enough, I don't have any of my hairy houseplants that I can easily move without destroying half their foliage. So I do have a leaf that I cut from one of them. And for the people that have been here for a while, you might be able to recognize a Chewbacca leaf. So this is a leaf of a Begonia seismorii. And I will bring it in a bit closer and hopefully you might be able to see, especially if I hide my face, you might be able to see some of those hair structures. You'll definitely see it on the petiole of that plant. And that's the thing I want to talk about today. So these hairy structures, and we've talked about this in other videos, but this is for the newbies that are joining for the first time. These are structures that on the plant, ironically enough, are called pubescence. There is a certain irony to the fact that teenagers start getting like bodily hairs everywhere, and that is also what it's called. It kind of takes inspiration from that when we're looking at hairy structures on plants. Now, there's usually a very good reason for plants having these hairy structures. They could be on the petiole, they could be on the leaf itself, it could be on the stem of the plant as well. But there is a good reason for them. And a lot of the times, things that look like hairs, obviously there is a scientific name called pubescence. I think sometimes as well they're also called trichomes. I think not always, but trichomes are another thing as well. So trichomes again comes from an ancient Greek word. So tricha, in at least modern Greek, is hair. So trichomes is a thing that looks like hairs. I kind of want to do the big fat Greek wedding thing. So there you go. It's originated from the Greek. But yeah, it is one of those things. And I've got my list down below so I don't forget anything. There are multiple ways that you can describe the fuzziness on a plant. Sometimes, I mean, this is a very specific example. I'll give you a plant that isn't always necessarily a house plant, but something like a lavender, which you might not think, but actually the lavender does have very, very specific trichomes or hair or pubescence on the leaves, and I think on the stem sometimes as well, and it does serve a purpose. More specifically, actually, it serves multiple purposes. One of it is to help reduce water loss through transpiration. If a plant is transpiring, it means it's kind of essentially breathing. So it's the exchange of gases on the kind of plant surface. I think pretty much a plant will transpire from every part of it. So the leaf, the stem, and the petiole. I might be wrong on that. But during this time where the stomata, we're going into a lot of very scientific words, there are cells at the very surface of kind of plant matter essentially, which look a bit, they look a bit like lips and a bit like mouths. Hopefully I'll find an image or a video and I'll add it up here just so you can understand what it means. And literally stoma or stomata literally means mouth or mouths in Greek again. So it literally just means because those cells look like little mouths and transpiration is the exchange of gases, you can kind of see what the scientists did there and just kind of went, the plant is breathing. So during that time when these cells, the stomata, open up to kind of exchange those gases, there is a chance that kind of moisture will be released at the same time. And by having these kind of hairy structures on the leaves, on the stems, on the petioles, it helps to reduce that loss of water that's happening during that time when the plant is transpiring. The pubescence will also help to deter pests. Some of you that have been here for a while, especially in my recent video where I was talking about the philodendron serpents, and I also mentioned the philodendron verrucosum, which have also got hairy fuzziness and the pubescence, and I will link that video at the top there. Not always the case, and it's not a foolproof, because I have seen a lot of the times with my more hairy plants, the one pest that doesn't seem to be too deterred by it tends to be mealybugs. I will say that a lot of the times, a lot of the other pests, as long as there's hair on it, they will not sit on there. So you'll kind of need to think of things like your spider mites. Thrips are another one that I've not seen on hairy plants, but mealybugs might be one that you might want to keep an eye out for. And the most obvious thing, I'm saying obvious, I'm assuming most people would assume this, it also helps to reflect some of the light back. I mean, this is probably not the greatest example on the surface of that leaf because you can't see that many hairs, but if you look at the stem, you can understand that it also helps it if there's in too much of a highlight situation, it will help to protect that plant because it will shade those initial kind of layers of cells from the rays of the sun or light coming onto it without stressing it out too much. And obviously, this is the obvious bit, insulation. There is one of those things that, like, the reason why animals stay as warm as they do during the winter months is because they've got thick fur or hair over their entire body. Plant is doing something very similar in terms of being able to insulate itself. Sticking on the topic of hairs, and I don't have one of these plants anymore. I used to have it, but hopefully I will add a picture or a video here. But this is, I don't think it's necessarily just specific to this one species of plant, but I might be wrong. Trigger hairs. So anybody seen a Venus flytrap? So a Venus flytrap, the way that it is, and say for instance, there might be a fly that lands on there, and the plant will close. That's the whole thing about the Venus flytrap, is that it catches flies. But I don't know whether or not a lot of people who have never owned a Venus flytrap will know this, but there are usually, I think, when I remember mine, I think it had 3 singular hairs on the inside of that trap. And those are trigger hairs. And it basically helps the plant make sure that it's only moving its foliage. I'm pretty sure that is foliage. If not, I will see and correct myself at the top there. But it will only move the trap to close the fly into it when those trigger hairs are triggered, basically. So, and I say 3 because if I'm not mistaken again, if something lands on one of the hairs, the plant is kind of like, ooh, think of it as a traffic light system. So green, red, and yellow, basically. So if it hits one of the hairs, it'll be on yellow and it'll be like, ooh, is it going to go green? Are we going to go? Are we going to go? And if a second hair of the 3 is triggered, then it will close. And essentially, it's a really smart way of the way that the plant does this is because it kind of makes sure that, you know what, if it's nothing, if it's something that's kind of landed on there and it's not something that I need to close for, thus consuming an awful amount of energy, because if you think about it, most other plants will not move as fast as the trap of a Venus flytrap. So it takes a tremendous amount of energy, which means the plant needs to conserve that energy, because if it expels it and it doesn't get a meal out of it essentially, or it doesn't get the nutrients that it's hoping to achieve by doing that, then it's kind of at a loss basically. And plants generally are quite smart when it comes to minimizing the loss of energy as much as they can, at least. So that's why you've got these trigger hairs. It tells the plant itself, you know what? Yes, I've had 2 or more trigger hairs that have been triggered. Something has kind of moved them around or essentially kind of stepped on them. Close it up, basically. And then more than likely, it will actually be what it's after, which is a fly or a bug or something that it can take nutrients from and not just replace the energy that it's used to close up, but also store some extra energy there. So very, very cool structures. As I said, I don't know whether or not this exists on a lot of other plants, but I know Venus flytraps specifically do have trigger hairs. And this was a lot of these actually that I'm going to be talking about today, the structures, were suggestions from the previous video's comments. So if you've got any more suggestions, do let me know down below and we can dive into it together. Moving on, and I've got another leaf because a lot of my plants are not easy to move at this point, but moving on to the topic of extra floral nectaries. So I will bring you an extreme example of this, and I will show you hopefully other pictures from other plants in the way that it might appear in other houseplants. So this is the back of the leaf, and hopefully you might be getting enough light on that that you might be able to see. If not, I will insert a video or an image. Did you see these little crystalline structures and maybe some salt and pepperiness? That is something called extra floral nectaries. And what it does is essentially it's the plant releasing a sugary substance, which is kind of a bit like a nectar that you might get sometimes on flowers. I'm thinking if you've ever had a Hoya or a wax plant, you might sometimes see that the flowers drip like this sugary substance. This is kind of a similar substance, and there are specialized cells that will do this. The reason why scientists believe that plants will do this is, and I love this adaptation that a lot of plants will have. This is one example. So this is the Piper crocatum, so the kind of pinky silver kind of Piper. This is one of the plants that will generally produce an awful lot of extra floral nectaries at the bottom. And this is something that sometimes worries a lot of people. And thanks to Tanya for reminding me about this on my previous video, because I can't believe I forgot to mention this. But it kind of comes across on the Piper as little granules, and it hardens off on the Piper as well. So little granules almost look like salt, and sometimes those granules oxidize, which basically means they're just exposed to the oxygen and it changes some of their structure and they change color. So some of it might look like salt granules, some of it might look like pepper granules. So it looks a bit like salt and pepper. And a lot of people, when they first get a Piper, they're just like, what is wrong with my plants? What are these pests that I didn't know about? No. It's quite normal. And I will say, with the exception of the odd mealybug, Pipers, as long as you can keep them happy, generally don't have an awful lot of pests. Now, I have had a lot of people that said about Pipers specifically that they've tried and it hasn't worked for them, and maybe what do I do? It's interesting because with the Pipers, the one thing that I will never do is remove them out of the soil media that I have purchased them in. At most, I will dress it on the top with extra soil or around if I'm going to pot it, but they've got very, very fine roots. They really do not like that being disturbed. And when they say that these plants need to be evenly moist, they are not kidding. It took a bit of trial and error for me to figure this out, but these are one of the few plants that in my collection, both winter and summer, sometimes there's a bit more in the summer basically, they are on a schedule. Most of my other plants are not on a schedule, but these are on a schedule. Every 4 days, I water them thoroughly and make sure that obviously they're not sitting in water. But sometimes the way that people kind of talk about the way that you should be watering ferns, very similar, I find, to Pipers, because when I let them dry out too much, they were not too happy. If I keep them too wet, they're not happy. But these are plants that generally, when you get that fine point, because a lot of the times I will water them even if it feels still relatively moist on the soil surface, not damp, it doesn't need to be sapping, but that's what I do. And I have had huge success with both the crocatum and the sylvaticum. I know I'm growing in here, so the humidity, I can't talk about what they would be like in household humidity, but the sylvaticum, I have taken a cutting, it is growing in pond, so semi-hydro, and it is also usually always got a water reservoir, and it is thriving. That's in regular household condition, right next to a door that even in the winter now is getting opened and closed, freezing cold temperatures, absolutely fine. The images or videos that hopefully I'm going to be adding to the side here is other examples of what extrafloral nectaries will look like on other plants. So I'm thinking sometimes on alocasias, on philodendrons, sometimes on anthuriums. You will get them on a whole spectrum of houseplants, basically. And it might be more kind of species specific rather than genus specific. I can't turn around and say all monsteras will have extrafloral nectaries, and I can't turn around and say all philodendrons will either. But a lot of the times, different species within that genus or family of plants are going to have extrafloral nectaries. And you might be asking why? Why produce extrafloral nectaries through these specialized cells that these plants will have? And again, this is the thing that scientists think it is because they are basically releasing this nectar. It attracts ants. So bear that in mind in your space if you're really worried about ants. And those ants act like the cavalry. So they will sit there and make sure that nothing attacks the plant. So kind of cool. A lot of the times you need to think about things like herbivores. So animals that might go and chomp on the leaves if it's covered with ants, because the ants are there taking this nectar and they're ready to protect this plant. That herbivore might get a nasty surprise when those ants then attack it, and then they will leave the plant alone. So see, that's really smart. Sometimes the ants will also take away and make sure that no other pests, so thinking more like insects will attack. Words are hard. We know this on a Sunday. They'll make sure that nothing attracts. See what I mean? Words. Nothing attacks the plant in terms of pests. There is one caveat that I've experienced, and I think a lot of people have experienced, is aphids. And I've got a video of an aphid here. What aphids do is the poop that they excrete, which is clear and fluid, is very similar to extrafloral nectaries. So what you then get is the ants protecting the aphids, not the plant. So then it raises a whole different set of issues, basically. And I know we're always talking about how we want to get rid of pests, but we do need to take a moment sometimes and realize quite how amazing nature might be. The fact that plants do this, they release this nectar in order to call in the cavalry, call in the ants to protect itself. And then a pest of the specific plant, the way that they got around it is by creating a similar nectar, calling in the cavalry to themselves, and it then means that they protect them, not the plant. Very, very cool. A little quick note to talk about something that was described, and I think most people will know what it is. Unfortunately, I have checked all of my propagation boxes. I do not have an example to show you, but hopefully you might know what I'm talking about. Have you ever taken a cutting? Usually this will happen with wet sticks, so a cutting that doesn't have leaves. It's just a stem cutting with a node. Have you ever noticed, and I think a lot of the times this might happen on monsteras specifically, that it gets a tiny little baby leaf at the node that doesn't really look like much of a leaf. It might look a bit like a leaflet, but it's not a kind of proper leaf. And somebody was just like, what are those things? So I did a bit of research, and as far as I could find, these are just kind of vestigial structures, basically. So it's something that was part of the evolutionary process of the plant. It's still there, it still happens, but it doesn't serve a massive purpose currently. But it might have been something that eventually would have turned into a leaf earlier on during the evolutionary process of the plant, or maybe it was something to do with how it was reacting to its environment. But as far as I could tell, there's not an awful lot of research that I could find that specifically spoke about this. The small amounts of information that I have been able to find is that these things are called vestigial structures. Another topic that came up that I did do a bit of further research into this. I had an inclination that it wasn't anything to worry about, or it wasn't anything specific, but a lot of people did mention brown spots on Alocasia, kind of petioles or stems. It's usually on a petiole that you would see it. And these are entirely normal structures to the plant. It's to do with that specific species. It might be the way that it would grow, the same way that you might get, let me show you again, this begonia leaf here. So you can see the different coloration that you're getting on the leaves. Very similar to that, basically. A really, really extreme example of this, when you think about alocasias, is something, and I might have a picture of the specific alocasia that I used to own years ago, the Alocasia zebrina. That does have that kind of zebra striping on the petioles of the leaves, and it's very similar in kind of appearance to those brown spots that you will get. I will sidestep on this a bit and say it could also be a couple of other things. Depends on what it looks like. So if it looks like the zebrina, nothing to worry about. It's the natural part of the way that the plant will grow, and it's a natural coloration of the petioles. If it looks like brown raised bumps, I have never had this pest, but it might be scale. Anybody who has had scale, do let me know down below if I'm talking rubbish, because I don't know, I've never had it. I don't know if it appears on alocasias, but I would assume it would. So if it is slightly raised and kind of bumpy, do a bit more research, have a look at it closer, get your phone, get into the highest zoom that you can get a magnifying glass if you're old school and you've got one of those, and check, because it might be scale insect, and then you need to deal with that basically. The other thing that it could be is what we were talking about just a moment ago, extra floral nectaries. Remember how I showed you the example of the piper, and I said specifically on the piper that you get that white crystalline structure and the black crystalline structure, and it's extra floral nectar that has hardened off, and some of it might not be oxidized, some of it might be oxidized. The dark one would be the oxidized. It's very similar sometimes that you get, and hopefully I think I've got a couple of plants that have currently got extra floral nectaries, and some of them are exhibiting this, and I will see if I do and add a video or a picture on the side here. Sometimes at the area where the plant is releasing the extra floral nectaries, you do get kind of browny, pinky kind of rings around that area where that nectar is being released. And if that nectar is no longer there, those markings remain. So what you might be seeing is that as well. Again, if it is extra floral nectaries, nothing to worry about. If it is just standard and decorative like you might get with the Alocasia zebrina, nothing to worry about. The one that you do need to worry about a bit and possibly deal with is if it is scale. But you should be able to see if there's a bit of a raised brown bump that it is a scale. Again, you're going to need to kind of go and look at it at a much, much closer level basically. But generally speaking, most of the time, nothing to worry about. Sometimes some people might also notice that with their Marantaceae family, so anything that's in the kind of prayer plant family, it might be a Maranta, it might be a Stramanthe, Tenanthe, Calathea. Also, I think some of them are now called Gopertias, so a whole host of different names basically. That's why I usually say the Marantaceae family, because I think that still stands, I think. So a lot of these plants, sometimes you might see that on a joint of the plant, so kind of along the plant surface, you might get another plant popping up. And believe it or not, this is also called vegetative propagation. So the same way that if you take a cutting from any of your house plants that has got a node and anything like that, and you propagate it, that is called vegetative propagation, where the plant will vegetatively propagate. The opposite of that would be sexual propagation. I think that's how it is. If not, I'll correct myself on there. Editing Memo is going to love having to dive into some of these more scientific bits further as well. But it is kind of when you think about seeds. So a plant will have a bloom, it will get pollinated, it will produce seeds. That's a different way of propagation, basically. And with vegetative propagation, though, we're kind of used to it with the cuttings that I'm talking about, but essentially it's the same thing that these plants are doing. A better example that might be more visually obvious if you've ever seen it, have you ever had something like a Sansevieria, again also been reclassified as Dracaenas now, but what we used to call snake plants, I think people still call them snake plants, I don't know why I say used to, but yeah, snake plants, you might see sometimes that you get different plants that are growing off the side of the actual main mother plant that you have. Alocasias will also do this in a slightly different way, but if you've ever unrooted a Sansevieria and you've taken the roots off, sometimes you might see the roots of the plant down below and you'll see branching out and then you'll see the plantners coming out. Essentially what it's doing is it's making sure that it's propagating itself by throwing out these plantners around it. It's producing progeny, it's producing little babies of itself around. Another one I think that does this is bromeliads. Bromeliads A lot of times people will see, and hopefully I will find a picture of a bromeliad. A lot of the times when you see a bloom, and they are generally sold, the more common bromeliads are sold with it being in full bloom, which is cheeky, I think, because a lot of the times bromeliads, that bloom means that plant is dying. It's monocarpous, I think is the word. So it will only bloom one time, and when it blooms, it's kind of last hurrah before it dies off, basically. It's trying to propagate itself through pollination. The interesting thing that a lot of bromeliads will do, and this is why it's not that bad that they're selling you a plant that's pretty much on its way out because it's blooming, is a lot of the times they will pup. Pupping is very similar. So we're talking about this in Marantas forms now, and you don't always think about Maranta pupping, but essentially it's what it's doing. It's throwing out and creating more progeny from itself. I'm trying to think now, there are some plants, some of the house plants that are called walking house plants, where they do this above the soil level, so you can see these connecting structures and then another plantlet that will be there. Very similar. Actually, I'll give you an example. Very common house plant, spider plants. Slightly different because it starts off like a stem and then there's a bloom on it, and then that will turn into a little baby plantlet, but it's essentially the same thing, but it would happen lower to the ground level, lower to the soil level. That's why that question I think came up, because they're just like, is this normal? What is it doing? Yes, it is. It's a way of it kind of propagating itself. And another topic that came up in the comments was somebody wanted a bit more information about rhizomes in plants. So rhizomes, you might be able to see it sometimes as little kind of potato structures. And actually, I think I might be able to show you an example on one of the calatheas, goproteas. I'm not entirely sure what everything is called these days. Annoyingly, no, I thought I'd seen some on one of my calatheas. It isn't there, but essentially what you will get is little tubers, so little potato-looking structures in and amongst the roots. It grows as part of the root structure. A more extreme example of this would be something like a colocasia or an alocasia. I think caladiums do this as well. Another one is the oxalis triangularis, the false shamrock. Words and tricky on a Sunday. So the false shamrock. These are all structures that the plants utilize in order to store nutrients and essentially self-propagate themselves sometimes. Obviously, the alocasias and the colocasias, it's trickier to see. But again, if you've ever taken an alocasia or colocasia out of a soil mix, have you ever found baby tubers? Have you propagated these baby tubers? Ta-da! So in nature, when that would still be in kind of the soil level, what you might then see, very similar to what you might get sometimes with bananas. And I don't think a banana has a bulb. It might have a pseudobulb. But it will self-propagate itself. It will throw out these kind of little extra tubers, and then it will grow from there. More extreme examples of this is, and I can think a bit more in terms of gardening, sometimes you can grow this in the house as well. So gingers will do the same thing. So if you put one lump of ginger in, you will usually get many, many gingers. That's an example of that. Something that I've added to the allotment recently, and everybody was just like, are you sure you want to do this to yourself? You're never going to get rid of it. I'm just like, I love the idea of that. Jerusalem artichokes, they'll do the same thing. Potatoes are another example where they'll grow multiple tubers, because essentially each one of those tubers has the chance to then become its own plant. So it is a way. It is also a structure where the plant will kind of store energy and nutrients as well as water. So it is little kind of baby clones of itself, so it can kind of multiply as well. Because ultimately, we need to remember that what a lot of plants are trying to do is survive and produce offspring, essentially. So this is an interesting one. Again, I've got my little trusty, like, this is kind of looking pathetic now. The Seismoria begonia leaf, basically. And somebody said, dive into a bit more, and I don't know if everybody's aware of this. So with begonias, most begonias, I'm pretty sure most, if not all begonias, you can divide the plant up, and that way you can actually get multiple plantlets. You can cut them at the stem, and then it becomes very similar to the way that we're used to propagating, so kind of through stem propagation, and get more plants that way. You can also literally take the leaf and the petiole and just stick the petiole. Usually this wouldn't work with most other houseplants. Stick the petiole in the soil and the petiole will root out. But then one thing that most people don't know is, and you might be able to see the veination on the back here, you can cut the leaf, cut a large chunk of the leaf off basically. But essentially at any point where you see a vein, however big or small, you can cut a section, stick that little leaf section that you've got, and I'll cut this now and show you basically. So if we just go like that, and can you see this kind of leaf structure there? It's got loads of veins. They're exposed along the cut. You'd obviously be doing this with sterile instruments and all of these things before you propagate, obviously. But I'm just trying to show you now, you would literally just shove this into a soil mix and eventually it will root out from the veins, which is exceptionally cool. It basically means that every single part of the begonia is capable of duplicating itself, which is absolutely insane. And if my research is correct, and I will correct myself at the top there because I'll look into it a bit more when I'm editing this, this is called vivipary. And vivipary is a form of asexual propagation. And this is, again, harkening back to what we were talking about before, which is the fact that if it's kind of propagation like this, or the little tubers that are coming off the side, or kind of creating little plantlets, or you taking and cutting these, are asexual ways of propagation. They essentially have exactly the same DNA as the parent plant would have. Sexual propagation would be the blooms being pollinated and then seeds being produced, and that would carry the DNA from both the parents. There is a debate that's been happening for a while, I think, in kind of terms of botany. I don't know whether or not there's a consensus yet as to which one of the two methods of propagation delivers more robust plants, if that makes sense. So if you think about something like a vegetative propagation, where you are essentially cloning the plant, you are cloning all of its kind of predispositions. So I'll make this in human terms. So if I clone myself and there's people in my family that suffer from like heart failure or heart issues, and I make another one of me, that other person that's exactly like me will have the same kind of genetic background and the same possibilities to, or higher chances of developing those heart issues. My family doesn't have this, by the way, don't worry. But as an example, so that would be the issue with the cloning side of things, is whatever the parent plant would have in terms of its genetics, the offspring would have exactly the same. Essentially, you're cloning it. So whatever it is there in the first specimen will be there in the second specimen. The sexual propagation, the seeds that are being created, because there's two parents providing DNA there, there's a higher chance that the offspring, that seed, and the plant that's going to come from the seed might be a bit more robust. It's not a guarantee, but if this specific plant, for instance, plant parent A versus plant parent B, so plant parent A has got a predisposition to certain kind of illnesses and kind of pathogens. I'm kind of giving you very extreme examples here as well. It doesn't work quite like that. And this parent doesn't. By them kind of creating a seed between the two of them, there is a very high chance that the seed that's going to be created from, it's going to take the DNA from plant parent B, which is robust against those diseases, and not have that predisposition to those diseases that plant parent A would have. Very similar, again, I'll use the example of mixed breed kind of dogs. I know somebody else liked an example that I used of a dog last time, but there is something that vets have been saying for a long period of time when you are getting mixed breed dogs, or what, I don't know if people still call them kind of mongrels essentially. A lot of the times those dogs specifically are much more robust against certain things like cancers or bone issues and things like that, because if dog breed A versus dog breed B, the offspring, generally the genetics, will always favor the stronger elements. Not always, but it will try to favor the stronger elements, which means that when you get a mixing of plant parent A that might have, or dog breed A versus dog breed B, both have, this one has issues with cancer on this side of the breed, this one has issues with bone problems. It might actually mean that this one not having bone problems and this one not having cancer issues, the offspring that will be generated from the two will be resistant to bone issues and resistant to cancer as well, or resistant, or more robust towards it as well. So very, very cool. But I do like to geek out a bit about genetics. It's so fascinating. Might just be me, but you know. Coming on to something that isn't part of a plant structure, but it is something that you might see growing around your plants sometimes. And I'm talking about little mushrooms that might be growing in the soil of your houseplants. I don't even want to give a percentage on this. A lot of the time, these mushrooms tend to be harmless. And I say a lot of the time because the person that I was having this conversation with in the comments, they were just like, oh, you should do this. And look, there's an example that's happening on one of my plants now. And I'm just like, that mushroom looks very different to the ones that I've always had. A lot of the times you'll get kind of whitish mushrooms that are growing off the soil of your plants. And generally, you need to start thinking about why this is happening and where mushrooms would grow naturally. So it needs high, kind of a rich area of organic material. So it might mean that you're using kind of regular plant gardening compost. You might still be doing all the right things and mixing it with perlite and things like that, but it might just be that much richer, basically, especially if it's kind of, and hopefully this is kind of getting weaned off for most of the world, compost that has got peat moss in it, but that might be favorable to these plants, and you're keeping these plants relatively wet for a long periods of times. I'm thinking people usually might get these on calatheas like we were talking about before, or ferns, because it's that perfect storm of the fungi, and it's the fruiting body. That's what people tend to forget. It's the fruiting body of what essentially is usually a very, very strong network of kind of mycelia, I think, or kind of their root structures in the soil. As I said, a lot of the times though, white mushrooms are harmless. They won't harm your plant. Most of these mushrooms generally won't harm your plant. The thing that I will say that you might want to consider doing is, if you are getting mushrooms, even if it's the white ones that generally tend to be harmless, and I'm saying this off the back of that conversation I was having with one of you, just remove it unless you specifically want to see that mushroom there. But there is a chance, like that example, that that mushroom might actually not be good to be consumed, basically, by either humans or baby humans, I'm thinking about children here, or pets. So generally speaking, if you've got little baby humans or pets, just remove those mushrooms. They're not causing any problems to your plant, but they might also be signifying to you. So for instance, if you're seeing mushrooms in something that needs to go fully dry, that might be giving you an indication that if a mushroom is growing in there, even if the plant hasn't started showing you signs of stress yet or root rot, you might be keeping that soil just a tiny bit too wet, because a mushroom should not be growing somewhere that likes to have a dry period between waterings. Does that make sense? And I'll finish off with a bang, and this is the weird white structure. And again, I don't think I've got anything in water propagations. I've got some water propagations. If I find one that has this, I will add the picture here. But hopefully you'll know what I'm talking about. Have you ever, I see this a lot of times with both philodendrons and monstera. Have you ever taken a cutting, put it in some water, and then before you start seeing anything like roots or anything like leaves emerging, you see these white, kind of almost crystalline, kind of opaque structures that are growing on that stem? And I say crystalline, it kind of looks kind of gnarled and it's a bit white, or it might go slightly on the beige side as well. And people are just like, especially when you're first starting off, I'm just like, I'm getting roots. And it's just like, it's been there for like a couple of weeks. I'm just like, that's not roots. What is that? What is growing on my plant there? So this one was an interesting one, because if you do a simple Google search, a lot of the times you will find that these things are called callus cells. Now, a callus cell would also be something that if you've cut a plant at any point, and usually they say let it callus over, it's the hardening that it will get because it's exposed to the air, just to make sure that it's kind of self-healing itself. It's the same thing that you would get if you've got, say, a cut somewhere on you, and you know that you will get clotting that will happen, and then you'll get that kind of scab. Essentially, the plant is scabbing over, so it kind of protects itself from kind of any further infection. And even if it's in the water, the callus is still going to be there. So that is one thing. However, these white crystalline structures are called something entirely different. They are a type of cell that you can get on calluses as well, but if you're not getting it on the callus and you're getting it on the stem, where it's growing usually somewhere near the node, these are called parenchyma cells, and I will add it at the top, or parenchymatous cells. And the way that you need to think of this, these are kind of normal cells that appear in the plant, and they might help with photosynthesis as well as other kind of functions of the plant itself. But think of these in that specific context. If you're getting them on something like the stem in water propagation, think of them like stem cells, like human stem cells. So essentially they are undecided cells. They can turn into anything. And at that point, they are trying to kind of make that decision on, do I become a root or do I become foliage, basically? And that's why sometimes you get a lot of people that get really frustrated going, my plant is growing, like my cutting is growing more and more foliage, but I have not had any roots yet. It's because the parenchymatous cells are deciding to turn into foliage first before they turn into roots. And as long as the plant isn't perishing for it, you should be fine, basically. But these are very cool structures, and most people kind of like something other than being, what is that weird thing, wouldn't necessarily know. But yeah, think stem cells. That's everything I wanted to cover. This is a particularly long video, and I have gone on quite a few tangents, and if I can, I will also add little notes on the different sections where you can skip the tangents. I know some people appreciate the tangents, so I do leave them in there. But yeah, if you like this and you want more of these kind of more scientific deep dive structure or processes videos, do let me know in the comments down below. I think the last one went down really well, and I think a lot of people kind of really were into it. And the one thing I will say, because a lot of the times, as you've noticed in this video, if I have images or videos or sections of plants that I can show you, I will do. But I might not always, like the parenchymatous cells that I was talking about now, I don't specifically have it at this point in time. So if you're reaching out to me on something like a DM on Instagram and you kind of having some suggestions, if you've got pictures and you are happy for me to use them in the next video, do send them over. And then I can pop them on the video and show an example to different people as to what it is we're talking about. But yeah, hopefully you've enjoyed. Hopefully I shall see you here soon. And I truly, truly hope that you have a great rest of your day. Thanks. Bye.